Hey guys, and welcome back. This is going to be the last video in our series on the material editor development. And it's been quite a long time since the previous episode. And the reason for that is that I wanted to essentially finish the editor and the material system to a point where I can actually use it to create content for the game that I'm working on. And I feel that now I have it, and I think it's a pretty good time to go through the system and see what we have, see what we can do with it. So if you've been following the series before, you might notice a few new things in the UI. For example, we have this window here called material perimeters, and this side also looks a bit different from the last video. And we'll get to these things in a bit. There's actually been quite a few new things added to the editor since the last video. But by far the biggest one, and the one that has the most impact, is the fact that I now have the actual export pipeline integrated into the application. So what does that mean? Well, if you remember from the last video, we have our materials here, and we were actually able to use those materials in the game already last time. And the way we did that was that we had this generated code window, and this is the window where the material editor generates our shader code. And so we were able to actually copy paste this into any text editor really, and compile it just like a normal shader, and then using that we were able to actually see the results in the game. But that's hardly a nice way to work, and in addition to this being sort of clumsy, it also didn't pick up on our render pass properties and other things that we had set in the editor. So that was sort of like a first proof of concept of using the new materials in the game. But now I have the whole system set up so that it actually produces the runtime format straight from the editor. So you can simply click export here, and you will see the result here in the editor log. So we can make this a bit larger perhaps. And so here you can see the whole output, and there's actually quite a lot of it. So we're exporting the material, jumping down to the bottom for some reason. We're exporting the material to this file. So this is a bin material file, and it's the same format essentially that we used before we even started this material editor project. So it uses the same sort of formats as the old style materials. And what it actually then does is that it passes it to this node material converter. This is actually a completely separate exe from the material editor. And the idea is that if you change something fundamental on the shader level, you should be able to just batch convert all the node materials from the command line. And because of that, I actually made it so that this editor itself doesn't actually convert anything. It passes it forward to this node material converter command line application, which then does all the conversion, even when you're actually initiating it from the editor, so to speak. So the next thing it does is that it generates the code for the render pass, and this is the opaque pass, is the one that we're actually looking at currently. And of course, if we haven't had an error here, this is as far as we would get. But we generated it successfully, and it actually uses the exact same code as it does to generate it here in this code window here. And then it forwards it actually to the shader compiler, and this is yet another exe. The reason for that is that this is actually written in C++ and native code, and the shader compiler is actually fairly complex at this point, and it compiles into a number of different graphics API shader formats, etc., etc. You can see some instruction counts here. This is actually kind of high. I have it as a separate project to actually go through and simplify the pixel shader like common functionality to get rid of some of those instructions, and that should be a lot easier now that we have a proper material system and editor. And yes, then it actually goes through and at some point it will either fail or succeed, and in this case we succeeded, and then it does the same thing for the other passes. So in this case we have 4 passes here. We have the opaque, which is essentially like the normal pass, then shadow map, and then a couple of different AO passes. The reason why we have 2 is that it supports both SSAO and HBAO. HBAO is typically what is used, but it's not supported on all platforms currently, so there's this SSAO pass as well. So this is very nice, and it's now fairly easy to actually make changes and see them almost instantaneously in the editor or the engine itself. So if we open up like the asset browser here and we look at, I think it was probably this one, I think. You can see this material that's sort of being sort of dissolved and then recreated here with sort of like a slight glow around the edges. This is something that I took inspiration from one of the Godot node material tutorials and tried to recreate it as much as I could. I'll put the link in the description below for the original video. And I use that as sort of a proof of concept, or like a test bed. Like, am I able to actually create this sort of material in my editor, and how easy is it to do? So let's see if we can find that that material here. Right, so it should be in Dev and UV sphere and dissolving sphere. And here you can actually see the whole. I'll try to make this a bit more visible. So this is the pixel shader, which creates this. We play with some noise here, and there's a new node that inputs the app time, which allows us to do this animation and etc. And so now if we do something like change this color here to something else, the only thing we have to do is hit export here in the editor, and you can immediately see it update there in the engine. So it's not exactly real time in the sense that you're not seeing like these sorts of changes here in real time like you do in something like Godot. But for my purposes, it's real time enough, shall we say. And it can be made faster still, because the shader compiler itself is sort of slow during certain passes. So that's an area where I can optimize it quite a bit to make the actual updates quicker. Okay, so what's the next new thing then? Well, let's perhaps start with this window here. I actually redid this completely. Previously I used a sort of tree control which came with the ST node editor component, which is the one that actually I use here to render and edit these node graphs. But it was kind of limited, and I didn't quite like how it did certain things, so I actually redid this completely. And one reason I wanted to do that was that I now have something called custom function nodes, and this is, for example, now a custom function node. So when you want to add a new node to the system. You can either do it using code, so that would produce something like this float operation node here, and this can have like fairly complex UIs, like drop-down boxes. It has these fields here where if you disconnect a pin, it will allow you to actually store the value straight in the node. And these are supposed to be very sort of general purpose, but they can be quite complicated, and they can, like I mentioned, they can store state. But they actually require you to make changes to the material system source code. So in effect, they are sort of part of the game engine. And quite often you actually need some custom shader functionality that is very sort of game specific. So for example, here I have something called the wind vertex animation. So this is not something that you would really want to put into the game engine itself. And if you needed to make a change or a slight variation of this, you don't really want to go into the source code of the engine and the material system to make that change. So how would we do that? So the solution that I came up with, like I mentioned, is called custom function nodes. And these are things that are actually stored in text files. So if we go to, I think probably the game data. Let's go here and to shaders there. And here we have a folder for custom function nodes. So let's open this wind vertex animation custom function node file. And I'll make this a bit bigger for you guys so that you can see it. And this is a format that I came up with. This is actually partially inspired by a blog post that I found online. I'll put the link in the description below. Niklas Andersson wrote a blog post about his similar sort of material editor, which actually you can just write a small text file like this, and it will sort of figure out what to do based on that. And he has a syntax here for this format, which is sort of similar to what I'm using here. So you have these comment and exclamation mark, and then some kind of name here which it parses and figures out what to do with. So this is the string here, for example, is the title of it, etc. And you specify input pins and you specify output pins for it. And then you can do some special code generation flags and preamble snippets. This is something that we went through in previous videos. So if you're interested in what those are, have a look at the previous videos. But the interesting thing is that, first of all, this custom function node can include headers. So inside this wind simulation header, you can actually create arbitrarily complex shader code. And in this example, we have this simple wind get position world space, and this is then defined in the wind simulation header. So the only thing we actually need to do to be able to call that is to insert the call in the correct place in the generated header. And anything that is not sort of commented out with these are considered code that is supposed to be inserted at the position of this node in the generated header file. So if you put a dollar and then one of the output pins, it actually knows to substitute this with the name of the output pin. And then similarly for percent signs, these map to the input pins. And this is something that's very handy, because now we can create, on the game side, we can create these arbitrarily complex pieces of code, like functionality, and then just create a simple text file like this and the editor will actually parse this on startup and generate the correct type for us, and also input them in the tree here, etc. So it's actually very easy to use now. There are some limitations, like for example, most of the built-in nodes have this feature that, like, if you disconnect the pin, like a float pin or a vector pin or something like that, you can just input the value yourself. But currently these guys don't actually support any state, so they're essentially just function calls, and a way to actually hook your custom code into the node graph. So that's custom function nodes. That's one of the new things that we have added since last time. And these are used, well, I don't have that many of them yet. As you can see, I only have 3, but these are already used in several of the new materials in the game, and without it would be sort of tricky to actually port all the old materials to this new system, because I would constantly have to go into the engine code essentially and change things up when I wanted to introduce new shader functionality. So these make it quite easy. So the next thing that I want to cover are material perimeters. So it's this new window here. And to do that, let's have a look at the spruce material that I created. And I think we'll go with this one. So let's quickly look at a spruce here. So unsurprisingly, it's a tree. It has a couple of materials, and had one material for the trunk, which has actually not been converted to nodes yet. And then it has another material for these leaves or for the branches. And this is actually a fairly complex material for several reasons. First of all, as you can see, it's a double-sided material. So you can see these sort of blades here. You can see them. You can see the branches both from the upper side and from below, and that's not something that's normally true. Typically, materials are one-sided, and that brings a whole lot of like complexity with, like, how do you actually light this underside when the normals are pointing the wrong way and all that. And of course, the other complexity with this is that this is actually animated. And as you can imagine, we're actually using the wind animation node that we looked at previously for this exact purpose. So here we have the material, and you can see here that we have 4 material perimeters. If I can make this a bit larger. Unfortunately, I can't enlarge these texts, so you're gonna have to actually squint a little bit if you are using a lower resolution. Sorry about that. But yes, these are essentially data members that you can add here. We can add a new color, for example, and we can set the color to whatever we want, and we can name it, green, for example, like this. And these perimeters are available to all the render passes and all the shader stages throughout the whole material, essentially. And they have this dynamic checkbox here, which actually currently is disabled because I haven't implemented that yet. But the idea is that when I get to actually implementing constant buffer support, so that you can actually update things on the fly at runtime, then this is the way I'm going to do it. Currently, you can't make them dynamic, so they're simply static. And you might wonder, like, okay, how useful is that? Well, it's actually very useful in a case like this, because here you have the diffuse texture, and this is a texture perimeter node. So it only gives you two choices here, the diffuse texture and the noise texture. And the reason is that they are the two texture perimeters that are specified for this material. And then when you go here, you can actually choose any available texture to map to that perimeter. And that can be very, very handy because, for example, this tree here uses alpha clipping, so it needs to have the same diffuse texture for all the passes. And previously what I've had to do is that I've had to go like, okay, well, I have opaque and I have shadow map here. So if I wanted to change this diffuse texture, I needed to go through all of these and change it here. And in those cases, I would not have like a texture perimeter node here, but I would have a texture resource node here. And then I could put in the texture directly here. But yeah, that's a lot of work to change one texture in several passes. And now I can simply make the same change here in one place, and all the passes can refer to these perimeters. Same thing with like wind strength and float, for example. Previously, if I wanted to change the way that the shadow pass the shadows are affected by the wind, I would go here and change it, and then I would have had to remember to go to the opaque pass and make the same change, etc. Now I can just have a float perimeter node here which reads the value from this list, and that's very handy. So now we can simply make the change here, and you can be sure that okay, it actually affects everything as long as you are referring to the perimeters from the individual passes. And there is another very handy feature related to the material perimeters. And that's something that's called a variant. So here, for example, we have a lot of different kinds of spruces, and many of these are actually just using either another texture or another color multiplier or something to generate these different colored trees here. And otherwise the material is exactly the same. So now that I have the material perimeter system up and running, I can actually create a variant of this material by going here and selecting create material variant. And the only thing that you're actually allowed to change in a material variant are these perimeter values here. And then if we wanted to make some really, really bizarre spruce, for example, we could set this to the fallback texture, for example, just as a test, like this. And now we can save it. And we can save it as leaves fallback, for example. And then we export it. And again, it exported successfully, and we should be able to see it here. And we can copy this bin material, and we can apply it here. So now we have this very weird looking tree with all the other perimeters and settings the same as previously, but we have another texture set, and of course we can increase the wind strength, for example, here, and just re-export it, and you should be able to see the wind affecting it a bit more. And so this is very handy because I tend to have a lot of sort of similar objects that are based on the same shader nodes. So we don't have to copy paste those nodes all over the place. You can just create material variants. As far as I know, Unreal has a system called material instances that are sort of the same. and the idea is the same anyway. And so it would seem to me that this is a pretty good way to handle this. All right, I think that pretty much covers the whole system so far. So now it's really up to me to start using this and converting things over to it, to actually to see if there's any like real problems or shortcomings with the system. I have some material still to be done here for the previous video series that we did when we essentially like modeled sort of this area. So now I can just go to town with the new material editor and create materials for all of these single colored objects here, and that's going to be a lot of fun. So I think this pretty much covers it for this video series. Thank you very much for watching, and as always, leave a comment, leave a like, or a dislike if you didn't like it. I'm also writing some stuff here in text form regarding the creation of the material editor, because I felt when I started this that it would have been really cool to actually have an in-depth blog post to read on actually creating a system like this for a custom game engine. I don't think there aren't that many people doing this sort of thing nowadays when you have all the nice ready-to-use engines out there. So I figured I'll actually just do it myself. So I'll put the link in the description to this as well, and check it out if you're interested in this sort of thing. And with that, I thank you for your time, and I will be back with more game development content soon. So see you then, thanks and bye.